All right, what is up, my play-by programmers? Welcome back to the Behavior Basics series. Today, we're going to be taking a little look at parameters. Now, parameters are a type of variable that exist within your behaviors, but they are exposed to the outside world, and they can be used by other components. They can be queried by um, other behaviors. They can even be looked at from other. They can actually be looked at and set by other units as well. So this is a great way for your units to be able to go and like physically talk to each other. So let's get into it a little bit. So when we take a look at our unit, right, we grab them here, and then we look over here. These are your parameters. And then these are also kind of technically parameters. They're registers, right? You've got, that is a scout radar, okay. So they're called registers, but they're basically the parameter of this component. And then these are the parameters of your actual unit here. So when we take a look at these are your parameters for this particular behavior controller. And that's actually very important because these parameters are locked to this behavior controller, right? So if I had another internal behavior controller, then they don't share parameters. I can pass the parameters between these two, but they are a part of this behavior controller, right? A parameter becomes a register for the behavior controller it's attached to. So let's go get into our behavior UI here, and let's take a little look at what a parameter looks like. So these are your parameters up here. They're part of your behavior. They get created. You don't necessarily have to create them on a unit, right? I can go into the library here and I can look at any of my programs, any of my behaviors, and I can see their parameters. So these become attached to the behavior controller when they get loaded into the behavior controller, right? So when you select your behavior, they become registers of that controller. So if we look in here, they're really easy to make. All you got to do is click them. And these are just variable locations that are exposed to the outside world that can be read just like any other component register. So if we look over here and we do like get from component remotely, we can use, right, we can get a reference to another unit, or we can use the reference of this unit right here, and then we can pick the register. So because this is an integrated behavior, we can click integrated behavior, and then we can count the registers just like we would with any other component, right? So this is register number 1 right here. So we could do internal behavior controller 1, and that would give us this value. We could do internal register, or we could do internal behavior controller 2, and it would give us this one. If we had another internal behavior controller, not the integrated, but an internal, then it would be down here in the components. I don't have the ability to make them on this playthrough, but then we could select the internal and we could pick which register, and it would be the same thing. And then we could use those to communicate between registers. We could set links, right? You could absolutely set links with these. So a link is when you take a register and then you like link it to another one. Nope, that didn't work. So you could set this register to your go-to location. You could set it to your store location. You could set it to your visual location, right? You can do all of that inside of your behavior. So this is what a link is. And you pick a from location and a to location. But that's how all of those movements work. And so parameters can be extremely helpful in not just getting data and manipulating it, but your parameters are a lot about how you're going to extrude that data back out into the world to do things, right? And share that data with other people. So a parameter can be any value. I can choose a value for it, right? I can set that parameter to crystal if I really want to. So it doesn't necessarily have to include anything that's going on in here, right? If I was just trying to create a parameter that somebody else was going to read, and I knew it was always going to be the same. For example, if this was like a mining behavior, and I put this mining behavior on a bunch of bots, and I wanted to number them or something so that things could read the parameter here. And then that would tell them which number mining bot it was. Then I could go over here and I could pick like crystal 10. And this could be like my number 10 crystal mining bot. And then I could just use that, right, as like an identifier for this particular unit if I wanted to. So it's just exposed data, right? And that data can be pulled from in here, right? I can pull from this output, from this node right here. It says get closest unit. I can take that get closest unit and I could set it up in a parameter. And then I could link that parameter to my go-to, right? And then that would be where I'm moving to. Or if this is supposed to be an enemy unit, then I could link this to a weapon. So if I had, let's see, let's pull this out. So if I had a weapon on here, then I could go ahead and link that to its target, and I could go attack whatever that unit is. There's all kinds of fun stuff that you can do with all of that. So some very good, easy logic here. But this is exposing those things to that outside. And that's very, very important. You can also pull things from a parameter. So for example, if I wanted to link two parameters, right? If I had two behavior controllers in here and one of them was running some other program, some other behavior, and information from that behavior periodically needed to pass over to this behavior, I could link one of these parameters to the parameter of that other behavior. And then I could use that data here on this behavior. And that's what this is right here, right? This is a download. So you've got upload data to the parameter, download data from the parameter. So here I'm pulling whatever this value is down into the value here. So this is input, this is output. You've got output going out, you've got input coming in. So there's all kinds of stuff you can do with that there. And then the last thing that you have is you have this parameter event. And this parameter event only fires when a value in a parameter changes. So this is a really great way to pull data from other places, link it into a parameter, and then run a certain code based on that. So I would pick my command parameter, and now this parameter event is triggered here. Actually, it would be better to pick parameter 2. Here we go. So now every time the closest unit to me changes, now I'll be firing a whole new set of code. right? Because this parameter is getting changed here. Whatever the closest unit to me is getting triggered to be here. And then as soon as I get that closest unit, the parameter changes. So boom. And this is also really great because this is only happening if the parameter actually changes. And so what that means is if I'm looping through this really quickly and I keep getting the same unit over and over again, I'm not actually changing this parameter, right? I might still be uploading this to the parameter over and over again, but because it's staying as the same value, this won't keep firing. It'll only fire when that information is different than the last time, which is really, really important. So it means that you can really control how often this information, this part of the behavior, is being triggered. And that's really powerful. And the last thing that we want to look at with parameters is parameters are not only exposed to the outside of the behavior controller, they're exposed to the outside of the behavior when you call a behavior. So right now, we've got a bunch of parameters here, and we've got a couple of them that we need to name. We're going to make this one output, and we're going to name this one input. And if we call this signal subroutine, let's go ahead and delete these. Okay, so if we call this subroutine that we're in, right, this behavior that we are currently existing in can get called by other behaviors as a subroutine. And we'll talk more about subroutines, but this is really important. So if we pull, whoops, I didn't save. Apply. So if we call that subroutine in the middle of another behavior, our parameters become exposed right here on our subroutine call. And that shows you sort of what these nodes are, right? These nodes are subroutine behaviors that were made as part of the game. And so they've got inputs, and sometimes they have outputs, and then they move on to the next little value here. And so you can create the same kind of stuff for yourself, right? So if there's a node that you kind of want, if there's a behavior that you know you're going to need to be running a lot in a lot of different places, then creating a subroutine for it can clean up your code and also be extremely, extremely flexible for you. And so this is what this means, right? We're pulling from this value down in here. And then we're uploading this closest unit value out. So we're just comparing, and this is a nothing program, right? It doesn't do anything. But because we're calling this program, now basically what we're saying is when we call this subroutine from another behavior, we are setting this value from the parent behavior. So I could go take another variable, like I could just copy, and I could set variable A here to whatever value I wanted, call it 6. And now what I can do when I call this subroutine is I can go ahead and take that variable A, I can set it into that input, and I can say, okay, now variable A is going to run here. And that's pretty cool. And then when I get my output, right, so I can come over here and I can set my output as a new variable. And we know that my output is going to be the nearest unit. And so then I can use that variable B to do whatever I need with whatever that nearest unit is. And so you can create all kinds of subroutines for all kinds of different stuff. And then you expose their parameters. And then you get this ability to pass information into and out of your subroutine. And this makes your behaviors, your subroutine behaviors, infinitely more powerful because now you can do lots of little stuff. If you want to make like an attack subroutine or something like that, then you can create a subroutine that pulls in a target and then black box all of the combat stuff and then output the resolution of the combat or all kinds of different stuff, right? Or if you want to do like some decision making logic, like should I attack or should I not, you can black box all of that. You can pull in the unit, the subroutine runs and says, does all of its decision making stuff, decides whether or not it actually wants to attack this unit, and then spits out a command like yes, attack, or no, don't attack, or whatever. And then you go through the rest of your code. And because you can attach these to parameter events, because you can attach these to radio events, you can attack these to all kinds of different stuff. You can get really, really powerful functionality jumping through lots of different subroutines to do different things. And so, this is object-oriented programming, right? You want to take individual methods, you want to take individual subroutines, and you want to separate them out so that you're not rewriting code, right? Because as soon as you write this subroutine, especially if it's something you think you're going to need in a couple of places, right? Create some good parameters for it. Set up some inputs and outputs. What are you doing with this data? How are you trying to manipulate it? What is going to be used or what is this going to be used for? Get the right inputs, get the right outputs, and then black box it into a subroutine so that you can just copy paste that anytime you want. Because this could be huge, right? We could have a massive behavior and it could just be run as a subroutine. It doesn't have to be something super small like this, but this is how you pass information into a subroutine and how you get information back out. And you have to make sure, so in order for this input to be an input, right? For example, if I delete these and then I save it, and then I call this again, and then I put the signal behavior back on there, all I've got is these inputs now. The game doesn't know that I have an output because I never uploaded a variable to an output location. So if you want to have outputs, you have to get a variable location, right? An output from another node, and you need to move it up to one of your parameters. And it doesn't work on inputs, right? If I move an input up here, it tells me, what are you doing? Right? I can drag the input down in, but I can't drag the input up and out. So your output of one of your nodes becomes the output of your parameter. And this doesn't have to be the end of your program, right? More stuff can be happening and get output later or never get output or just do some stuff, like whatever. But this is effectively the end, because anything that you do after this point is not going to get part of this output. So down here where you're calling this subroutine, nothing that happens after here is going to affect this. But yeah, parameters are just your externally exposed variables at all levels. They're externally exposed here in subroutines. They're externally exposed out here where you can look at them and you can manipulate them and you can query them and you can do all of that stuff. So parameters are super, super valuable. And once you get the hang of how to use them, your behaviors are going to be able to be infinitely more complex. So, yeah, I want to thank everybody for coming and hanging out today. If you got any use out of this video, don't forget to hit the like and subscribe. And I will see you all on the next one for arrays.